Okay, so if you want that expression into a DFA, so say we had AB star, I think this was, yeah, AB star or AB star in brackets. So yeah, what I always do first is I convert it into an Epsilon-NFA. So we can either, so we have our start state, and then we can either take in an A and then any number of B's, and that will be accepted, or we can take in an A and then a B any number of times, like this. The reason I put this arrow here is just so that we can separate this as a separate sort of thing, just so that, because if we did something like A here and then B here, then we could mix and match these two, but we don't really want that. We just want it to either be this or this, and this just represents the OR. We could even just, to make this OR even clearer, put an epsilon here, like that. But I mean, yeah. So that's the Epsilon-NFA for that. Do you see how I've got that? And then, okay, cool. And then I convert that into an NFA, so removing all of the epsilon transitions. So removing the slow accepting states and the slow transitions. So from the initial state, slow transition is this A to this accept state here. And then slow transition to here is we can just have an A going straight to that state. We can also have the B then going back to this accept state. And then from that B, we also have this A going back here. So I've removed all of the slow transitions. Any slow accepting transitions, the only one we had was this one, because this was an epsilon. So if we get rid of this transition, this also can become an accept state. So then after removing all of the epsilon transitions, I get to this NFA here. And then we just need to determinize it. So if we give all the states a number, then our initial state is just 1. So we can start at the set of states, which is just 1. Reading in an A from 1, we can go to 2. Or the new set of states, which is just a 2. 2 is, this would be an accept state because 2 is an accept state. And then from here, if we read in a B, or actually, so yeah, A can either take us to 2, but we can also read in an A and go to 4. So this would actually be a set of, should it not? Yeah, that's fine, because it would go into this first part of the OR and it would just read A and then 0 B's. No worries. Yeah, so if we read an A from 1, yeah, so this should also be marked as accepting, because 1's an accepting state. If we read an A from 1, we go to 2, 4, so we can either go here or we can go here. And if we read a B from 1, we can just go to this error state, because B is not defined from 1, and then this can just have a reflexive AB, so we're stuck here. Okay, and then if we read an A from 2, 4, we can go to, okay, error state again, nothing we can do from there. If we read a B from 2, 4, we can either go to 2, or we can go to 3. So this would now go to 2, 3 in a set. Because that 2 is accepting, this state would also be accepting. And then from 2, 3, so this was if we read in a B, yeah, okay. So then we look at A from 2, 3 and B from 2, 3. So from 2, 3, if we read in an A, we won't get anywhere from 2, and from 3 we'll get to 4. So from here, we'll just get to 4. 4 isn't an accept state, so this would just be a normal state. If we read a B from 2, 3, we can either get to 2 or nowhere. So we can just get to 2 on its own here by reading in a B. 2 is an accept state, so this state would also be an accept state. And then from 4, if we read it in an A, we can't get anywhere. So that can just go here. If we read in a B from 4 though, we can get to 3. So then we'd have a state for 3. 3 is an accept state, so that can be an accept state. Then B. And then from 2, if we read an A, we can't get anywhere. If we read a B, we just go back to 2. So this can just be an arrow like that. And the last one we need to look at transitions for is 3. So if we read an A from 3, we go back to 4. And if we read a B from 3, we just go to our error state. So then this would be our totalized DFA. I believe all the transitions are defined. So that's how we'd convert, well, that's how I'd convert that regex into a DFA, just by going step by step, starting with an Epsilon-NFA, because I find it a lot easier to write out a regex as an Epsilon-NFA and just stick epsilons everywhere, because we can then systematically get rid of it all when we then remove all of the epsilon transitions. Does it have to be a complete DFA, or can it be partial? I think it can be partial, but just to be on the safe side, I always like to totalize it and just have everything go to that error state in case. But yeah, that's what I'd do.